Okay, so if you're building anything with AI these days, you're basically swimming in vectors. And when you've got millions or even billions of them, finding the right one and finding it fast is, well, it's everything. Today, we're going to break down the three powerhouse algorithms that make that fast vector search actually possible. Let's dive in.
All right, picture this. You've got a million vectors. A user sends a single query. Now, to find the one perfect match, your system literally has to run a million distance calculations. 1 million. That is painfully slow. And this right here is the core problem every single AI builder hits when they start to scale. So right away, you're at a crossroads. You can have exact search, which, yeah, it gets you 100% perfect recall, but it takes forever. Or you can go with approximate search. This is where we might trade a tiny, tiny sliver of accuracy, like getting 99% of the right answers instead of 100%. But in exchange, we get a massive, maybe even 100-fold boost in speed. We're talking milliseconds instead of seconds. And look, for pretty much any real-world app, that trade-off is a total no-brainer. And that right there is what we call the high dimension dilemma. When you're operating at scale, chasing perfect accuracy is the absolute enemy of a fast, snappy user experience. The goal here isn't perfection. It's about being crazy fast and almost perfect. And that's exactly where indexing comes into play. So how do we actually solve this thing? Well, we've got a toolbox for it, with specialized tools designed for the job. And today, we're going to get to know the big three: HNSW, IVF, and PQ. Okay, first up, we've got HNSW. It stands for Hierarchical Navigable Small World, but don't worry about that. Just think of it as a high-speed navigation system for your vectors, like a multi-level superhighway. This thing is just obsessed with one thing and one thing only: raw query speed.
Then there's IVF, or Inverted File Index. Think of this one as your super organized librarian. Instead of running around the entire library looking for a book, it groups similar books, or, vectors, into sections. So when you have a query, it only has to check the most relevant shelves. It's a huge time saver. And wrapping up our trio is PQ, which stands for product quantization. This is the expert compressor of the group. Its superpower? Taking these huge, chunky vectors and shrinking them way, way down, which slashes their memory footprint. This is the secret sauce that unlocks search at the billion vector scale.
Okay, so we get what they do, but how do they actually pull it off? Let's pop the hood for a second and take a quick look at the mechanics behind each of these tools. So HNSW, it builds this really smart multi-layer graph. Think of the top layers as express lanes on a highway. They have these long-range connections that let you jump across the whole data set really fast. Then, as you get closer to your destination, you move down to the lower layers, which are like local roads with dense, precise connections. And what you get from this setup is an incredible balance: amazing recall and query speeds under 50 milliseconds. The catch? It uses a lot of memory. Now, IVF takes a totally different approach. It uses a clustering algorithm to pre-sort all your vectors into a bunch of different cells. Then, when a query comes in, it doesn't search everything. It just checks the handful of cells that are closest to your query. This is a fantastic strategy for those big, static datasets, where you can do all that organizing upfront. The trade-off here is that it's usually a bit slower and has lower recall compared to HNSW. And then we've got PQ, which is just all about one thing: compression. It takes your vector, chops it into a bunch of smaller subvectors, and then, this is the magic part, it compresses each of those pieces into a tiny little code. And this is its core strength. You get a massive, sometimes up to 30x reduction in memory. And that is your ticket to handling these absolutely enormous datasets. But it does come at a cost to accuracy, with recall often dropping into that 70 to 90% range. But here's a cool thought. What if you could combine them? Well, you can, and people do it all the time. Using IVF with PQ is pretty much the industry standard for gigantic datasets. IVF does the first pass, narrowing the search down to just a few clusters, and then PQ lets you search inside those clusters with the super compressed, memory-friendly vectors. You get the best of both worlds, and it's basically the gold standard for huge scale. All right, so how do these three actually stack up against each other in the real world? It's time for a performance showdown. Seeing these trade-offs side by side really makes it click when you should use each one.
Okay, just looking at this table, the story really starts to write itself, doesn't it? HNSW is your undefeated champion for speed and recall, but man, it is a memory hog. IVF is that solid middle ground, especially if your data doesn't change much. And anytime you hear billion scale or huge data set, your brain should immediately be thinking PQ, or that IVF plus PQ combo, because they just crush it on memory efficiency. And wow, if we just visualize the query time, the difference is just staggering. I mean, exact search is way off the chart. IFF brings it way, way down to something manageable. But HNSW, it's literally in a league of its own. For any app that needs that instant, real-time feel, this chart tells you everything you need to know about why HNSW is so often the default choice.
Okay, enough theory, let's get practical. You're spinning up a new project. Which one of these do you actually pick? Here is a dead simple guide to help you make that call.
You know, a really simple place to start is just how big is your data set? As a rule of thumb, if you have under, say, 10 million vectors and you absolutely need speed, HNSW is probably your best friend. Once you start getting into that 10 to 100 million range, IVF becomes a really strong contender. And then, once you cross that 100 million vector mark, the memory savings you get from IVF plus PQ become pretty much essential. So here's a simple 5-step playbook you can follow. 1. Analyze your scale and your needs. How much data? How fast does it need to be? 2. Choose your algorithm based on that. 3. Just start with the default parameters. Don't overthink it. 4. And listen, this one is so important. You have to benchmark your recall and latency. And finally, 5. Tune those parameters until you find that perfect balance for your specific use case. And that leads me to probably the single most important thing I'm going to say in this entire explainer. The theory, the defaults, they're great starting points. But nothing, and I mean absolutely nothing, is more important than benchmarking on your data. The way your specific vectors behave will determine the final result. So you have to measure, measure, measure. So there you have it. You're now armed with the knowledge to pick the right index to make your vector search blazing fast and ready to scale. But, speed is only half the battle. How do you make sure the results you're getting back so quickly are actually meaningful? That they have the right semantic context? Well, that's a whole other story, and a topic for another day.